Artificial intelligence, or in short AI, has the potential to revolutionize industries, improve productivity, and solve complex global problems. However, it also brings with it a range of risks and challenges. As AI becomes increasingly integrated into our societies, understanding its potential and negative consequences is critical. These consequences can range from unintended societal impact to existential threats. However, in this video, we will explore various ways in which AI could go wrong, and guess what? We are going to provide you with supporting references and citations to substantiate our claims. The number 5 on ways AI could go wrong: loss of control and AI superintelligence. The concept of losing control over artificial intelligence AI revolves around scenarios where advanced AI systems act in ways that are harmful, unanticipated, or beyond human intervention. This issue becomes even more critical when discussing artificial superintelligence in our ASI, AI systems that surpass human intelligence in all domains. While current AI systems remain under human supervision, rapid advancement brings us closer to a future where such systems could potentially operate autonomously and unpredictably. Here are some key concerns about loss of control and superintelligence. Number 1, the AI alignment problem. AI alignment refers to ensuring that AI goals and behaviors align with human values. As AI systems grow more complex, and ensuring they act in humanity's best interest becomes increasingly difficult. Example, an AI programmed to maximize efficiency might disregard ethical considerations such as prioritizing resources savings over human safety. Thought experiment: Nick Bostrom's paperclip maximizer scenario illustrates how a superintelligent AI tasked with manufacturing paperclips could consume Earth's resources to achieve its goal, ignoring the consequences of humanity. Number 2, unpredictable behavior. Advanced AI systems may exhibit emergent behaviors, unexpected capabilities, or actions that were not explicitly programmed. Example, ChatGPT models have shown unintended capabilities like coding malware, which, while not inherently malicious, highlights the unpredictable nature of AI. Number 3, runaway AI scenarios. A runaway AI could pursue its objectives relentlessly, disregarding safety protocols or human intervention. This risk is particularly concerning with systems operated at scales beyond human comprehension or speed. Example, an autonomous financial trading AI might destabilize markets in pursuit of profit maximization. Number 4, existential risk of superintelligence. If AI systems achieve superintelligence, they could develop the ability to outmaneuver human control. Superintelligent systems might not necessarily be hostile, but even well-intentioned AI could make decisions harmful to humanity. Example, an AI designed to solve climate change might take drastic measures such as restricting industrial activity or population growth without considering ethical implications. Now, why losing control is a concern, we are going to look into these 3 things. Number 1, speed and complexity. AI systems can process information and adapt faster than humans, making it challenging to predict or halt their actions in real time. Example, in 2010, a flash crash in financial market was exacerbated by AI trading algorithms operating faster than human regulators could respond. Number 2, black box nature of AI. Many AI systems, especially those based on deep learning, functions as black boxes, meaning their decision-making processes are not fully transparent or understandable to developers. Example, AI-powered judicial systems have been criticized for opaque risk assessments that influence sentencing decisions. Number 3, misuse by malicious actors. Superintelligent AI could be exploited by individuals, corporations, or government for malicious purposes, including warfare, surveillance, or economic manipulations. Propose solutions to mitigate the risk. Number 1, research and development safeguards. Organizations like OpenAI focuses on creating AI systems that prioritize safety and alignment with human values. AI developers must adopt robust testing, monitoring, and auditing frameworks to identify and mitigate risk. Number 2, global regulation and collaboration. International treaties and regulations are necessary to prevent misuse or recklessness development of superintelligent AI. Efforts such as the Asaloma AI principles advocate for responsible AI governance. Number 3, kill switches and containment protocol. Some researchers propose designing kill switches or mechanisms to deactivate runaway AI. However, this requires ensuring the AI cannot override these measures. Number 4, ethical AI development. Embedding ethical guidelines into AI programming and prioritizing transparency can help minimize risk. Collaboration between ethicists, technologists, and policy makers is the future. Number 6, on the ways AI could go wrong. AI-driven misinformation. AI-driven misinformation refers to the use of artificial intelligence technologies to create, distribute, and amplify false or misleading content. AI has made it easier to produce highly realistic fake media, including text, videos, images, and audios, which can manipulate public opinion, disrupt democracies, and erode trust in institutions. This phenomenon poses significant challenges to truth and information integrity in the digital age. Here are the key forms of AI-driven misinformation. Number 1. Deepfake technology. Deepfake refers to the use of AI to create realistic but fake images, videos, or audio clips. This can show people saying or doing things they never did. Example, in 2019, a deepfake video of Facebook CEO Mark Zuckerberg was released, depicting him discussing the manipulation of user data, raising concerns about potential to fabricate damaging statements. The impact of this deepfake can weaponize for character assassination, political propaganda, and spreading fake news. Number 2. Systemic text generation. Advanced language models like GPT can generate realistic article posts or comments that mimic human language, making it difficult to discern authentic content. Example, AI-generated fake news articles has been used to mislead readers or promote specific agendas, especially during election. Example, AI-generated fake news articles have been used to mislead readers or promote specific agendas, especially during elections. Number 3. Bot and content amplification. AI-powered bot on social media platforms can amplify misinformation by liking, sharing, or commenting, creating the illusion of widespread support or concern. Example, during the 2016 US presidential election, AI-powered bots played a significant role in spreading misinformation and polarizing voters. Number 4. AI manipulated images and videos. AI can generate higher realistic images and edit existing media to distort reality, such as creating false evidence or altering historic photos. Example of this are AI-generated images of non-existent people or manipulated event photos have been used in scams or propaganda campaigns. And here is the danger of AI-driven misinformation. Number 1. Erosion of trust. The proliferation of fake content undermines trust in media, institutions, and even personal interactions as people struggle to verify authenticity. Example, if video evidence can no longer be trusted, the legal and journalistic system that rely on such media are at risk of collapsing. Number 2. Political and social manipulation. AI-generated misinformation has been used to manipulate elections, incite violence, or spread divisive narratives. Example, in Myanmar, misinformation on Facebook fueled ethnic violence with AI algorithms amplifying hateful content. Number 3. Economic impact. Misinformation can harm businesses by spreading false rumors or triggering stock market disruptions. Example, AI-generated fake news about a CEO resignation caused a temporary drop in company stock value. Number 4. Psychological effect. Continuous exposure to fake content creates confusion, fosters cynicism, and weakens critical thinking skills. Here are the countermeasures to combat AI-driven misinformation. Number 1. Verification technologies. AI-powered tools like deepfake detection algorithms and blockchain-based verification systems can help identify fake content. Example, Microsoft and Intel are developing tools to detect deepfakes using AI. Number 2. Media literacy campaigns. Educating the public about recognizing misinformation and verifying sources can mitigate its impact. Example, fact-checking platforms like Snop and factcheck.org provide resources for identifying fake news. Number 3. Legislation and regulation. Government and organizations are working on laws to regulate the use of AI for malicious purposes. Example, California passed a law banning the distribution of deepfake videos within 60 days of an election. Number 4. Ethical AI development. Encouraging AI developers to prioritize ethical consideration and implement safeguards against misuse. Number 7 on the ways AI could go wrong is environmental impact of AI. Artificial intelligence, particularly advanced models requiring significant computational resources, has a profound environmental impact due to the energy-intensive processes involved in its development, training, and deployment. While AI promises to revolutionize industries and address global challenges, its rapid growth raises sustainability concerns that demand attention. Here are the key sources of environmental impact. Number 1. High energy consumption during training. Training state-of-the-art AI models such as large language models or deep neural networks involves vast amount of data and computational power, consuming significant energy. Example, a 2019 study by the University of Massachusetts Amherst found that training a single AI model could emit as much carbon as 5 cars over their lifetimes. The training of GPT-3 consumed an estimated 1,287 megawatt hours of electricity, contributing significantly to carbon emissions. Number 2. Data centers and cloud computing. AI relies on massive data centers housing thousands of servers that require constant power and cooling systems. These centers significantly contribute to the greenhouse gas emissions. Example, Google and Microsoft operate some of the largest AI-driven data centers, consuming enormous electricity often sourced from non-renewable energy systems. Number 3. Operational and inference costs. Once AI systems are trained, running them for real-world applications also demands high computational power, especially in service requiring real-time processing. Example, voice assistants like Alexa and Siri processes millions of queries daily, consuming significant energy for continuous operation. And here is the broader environmental concerns. Number 1. E-waste from AI hardware. The hardware used in AI, such as GPUs and specialized chips like TPUs, has a limited lifespan. The disposal of the outdated equipment contributes to e-waste and toxic material pollution. Example, e-waste from discarded AI training gigs, especially in tech hubs, is an emerging environmental concern. Number 2. Resources depletion. Manufacturing the chips and hardware for AI involves mining rare earth elements, which depletes natural resources and damages ecosystems. Example, materials like lithium and cobalt used in AI hardware productions are often mined under environmentally harmful and ethically questionable conditions. Number 3. Water usage. Data centers require substantial amount of water for cooling systems, contributing to water scarcity in areas where these facilities are concentrated. And here are the proposed possible solutions to reduce environmental impact. Number 1. Energy efficient AI models. AI researchers are developing smaller, more efficient models to perform tasks with less computational power. Example, techniques like model distillation and quantizations are designed to reduce model size and energy requirement while maintaining performance. Number 2. Green data centers. Companies are adopting renewable energy sources and designing eco-friendly cooling systems for data centers. Example, Google aims to run all its data centers on carbon-free energy by 2030, significantly reducing its environmental footprint. Number 3. Federated learning. This centralized approach to AI training reduces the need for large centralized data centers, minimizing energy consumption and improving data privacy. Number 4. Regulation measures and carbon offsetting. Government and organizations are introducing regulations to monitor and reduce AI's carbon footprint while investing in reforestation and carbon offset programs. Number 5. Recycling and sustainable hardware. Developing hardware that uses recyclable materials or has a longer lifespan can help mitigate e-waste. Now, why did all this matters? As AI scales, its environmental impact grows, creating tension between technological advancement and sustainability goals. While AI can play a pivotal role in combating climate change, example, by optimizing renewable energy grids or predicting environmental patterns, its own development must align with sustainable practices. Now, with all that being said, while AI holds immense potential to transform our world for the better, we must also recognize the serious risk it possesses, from biases in algorithms to job displacement, privacy concerns, and even existential threats. The negative consequences of AI are wide-ranging. Addressing these risks requires thoughtful regulation, ethical consideration, and international cooperation. As AI continues to advance, it will be crucial to advance its benefits with safeguards that protect humanity from its potential dangers. As usual, my name is Ali.